Hello and welcome back. Now, in the last video, I said that we were going to be giving an introduction to WEL 512 as well as doing some setup for our implementation of WEL 512. Well, the video ended up being just an introduction. So let's go ahead and take a look at getting the setup done in this video here. Lee?
Yeah, let's start off by closing up some of this stuff. There's a whole bunch of stuff in here right now, and I just want to close it up, make it a little bit easier when we're scrolling back and forth to test stuff. Now, there's a couple of fields that I want to get set up in the myRandom class, and then I want to get the constructor up and running. So that's what we'll be doing in this video. So the very first field that we're going to bring up is going to be a uint, not a unit, uint. And this will be an array. We're going to call this state. And we'll go ahead and initialize it. Now, one of the things that I want to point out is we're going to be very, what's the word I'm looking for? Not varying, deviating from the original code that we have. If we jump back over to this paper that we've got for random number generation, and I scroll back down, I think 512 is right around in here somewhere, just a little bit higher. Okay. Now, Jason and I went back and forth discussing this, and we had to do some tests just to see what would happen. But if you look at this code, it's talking about using unsigned longs. And if you see what we're using unsigned ints. Now, the reason for this is in C#, unsigned longs are 32-bit values. And inside of here,
In C Sharp?
Or sorry, in C++, C++, unsigned longs are 32-bit. Inside of C#, ulongs are 64 bits, or unsigned longs are 64 bits. So to keep the code consistent, we're going to be using uints to start with. Now, this was kind of interesting, and this is what Jess and I were discussing, is I had coded it exactly or not exactly the way because I had to vary for the language differences, but I had used ulongs for all of my arrays and variables, which gave me additional precision. So the numbers that I was getting were even better than what I was supposed to be getting based off of the WEL 512. So in essence, it was kind of like kludging my way through a variation of the WEL 1024.
Mm-hmm.
So I had double the precision. So we're actually going to kind of leverage that fact later, but because the original algorithm is written to be to use 512 bits in its state and not 1024, we're going to vary from the original code and use uints instead of the ulongs, at least for this first part of it. Now, we also need to have another field. This one will be another unsigned int. This one will be index. This is going to hold our current position inside of our state array of where we're at when we're working. Because the way 512 works is it does a whole bunch of bit shifting back and forth between various elements of this array, and then it keeps its index of where it's going to start next. So it's always doing shifting, and then it modifies its index, and then the next time you come around, it picks up at that same spot again, and then continues from there. That's how the algorithm works, in a way that it's always generating the next number in the sequence. So the next thing that we need to do is not a private. We actually need a public myRandom. So this will be our constructor. And we need to basically initialize our random number generator. So we're going to accept a uint, call it seed. Go ahead and put the brackets in. So what we want to do is we want to start off by setting the first element in our state array to be equal to our seed. So what we're going to be doing in the constructor is initializing our state array, and we're going to also initialize the index. So every time you create a new array, we can go ahead and reseed it. Or we'll create a new array, give it its seed, that'll initialize the array.
Mm-hmm.
So let's see. We're going to, oh, that didn't work the way I was hoping. There we go. All right, so I'm going to run through the loop of our array. So we're going to look for our state's length. Now, because we've already initialized the first element, and I'm going to rely on the fact that this first element is initialized already, we're going to start our counter for the loop at 1 instead of 0. And then what I'm going to do is say state element I equals state element I minus 1. And then I'm going to multiply it by 47. This is just I'm just using a prime number here. So you could experiment and use different prime numbers if you wanted to. There's no problem with doing that. And then we set our index to be 0. Now, while I think about it, I also want to add another method. Might as well. Let's do a public void. We'll call this method reseed. And then what I'm going to do is I'm going to take all the code that I put in the constructor, and I'm going to put it here inside of reseed. And then inside of our constructor, I'll call reseed and just pass it the seed. So this will give us the ability to initialize our array that we have to an initial value, but it also gives us the ability, if we've instantiated one of these my random arrays, and for whatever reason we want to go ahead and reseed it and reset it to a new sequence of numbers, this will give us the ability to do that without having to destroy the old array and start off with a brand new one, if you wanted to do it for whatever reason. So, but that is the initial functionality that I wanted to get ready to get the setup for dealing with the actual core functionality of Well 512, which I want to get to in the next video.
All right, fantastic. Well, with that then, that is going to wrap up this video.